Welcome to the PDE TNSET online classes. Yes, I welcome you. I welcome to Senthil Nayaki ma'am for our today's resource person, and also I welcome all the aspirants who have prepared for TNSET online class. Okay, so thank you all.
Thank you so much, sir. Greetings to one and all. Now we are going to discuss about the solution procedure for the higher order partial differential equations. So in the higher order partial differential equations, already we have discussed about the exponential case and the polynomial case. If the right-handed side function is exponential, then we have discussed that case for finding the particular integral the last session. And also, if the right-handed side is a polynomial in x and y, then the solution procedure for that means for finding the particular integral had been discussed in the yesterday class. Now we are going to discuss about the third type, that is either cos ax or cos ax plus by cos ax plus by or sin ax plus by. It is a trigonometric term. For this problem, we are going to discuss, we are going to use these four formulas. These are all very known formulas in the trigonometries. 2 sin a cos b is sin a plus b plus sin a minus b. 2 cos a sin b is sin a plus b minus sin a minus b. 2 cos a cos b equal to cos a plus b plus cos a minus b. 2 sin a sin b equal to cos a minus b minus cos a plus b. In this case, we have to find out in the question for finding the particular integral. First, we have to collect a and b values. After collecting a and b values, we have to find out these terms. The first one is d square. This d squared is replaced by minus a square. Now we have a and b. By using this a and b, we have to find out d square, d dash and d dash square values. How can we find means d square equal to minus a square, d dash equal to minus ab, d dash square equal to minus b square. Simply we can find all these values. Now let us see one example for in this type. The question is solve d square minus 2d d dash plus 2d dash square into z equal to sin x minus y. In the last class itself, we have discussed what is d and d dash. D dash is the derivative with respect to x, and d dash is the derivative with respect to y. Partial derivatives. Both are partial derivatives. Z is the dependent variable, and x and y are independent variables. For finding the complementary function, the same procedure in all cases. So replace d by m and d dash by 1. Therefore, we get dm square minus 2m plus 2 equal to 0. Therefore, the roots are 1 plus or minus I. So, there are two complex roots. First root is 1 plus I, second root is 1 minus I. So, the solution, that means the complementary function for this complex roots is pi of y plus 1 plus I into x, that is the first root, plus pi 2 of y plus 1 minus I into x, this is the second root. Now we found the complementary function. Next we have to find out the particular integral. So particular integral means the procedure is 1 by d square minus 2d d dash plus 2d dash square into sine of x minus y. So here the coefficient of x is a, therefore a equal to 1. Therefore a equal to 1. And b equal to minus 1 because the coefficient of y is minus 1. Therefore b equal to minus 1. Next we have to find out the value of a square, ab and b square for replacing the value of d square, d dash and d dash square respectively. So a square value is 1, ab value is minus 1, b square value is 1. Replace d square by minus 1 and d dash by minus 1 and d dash square by minus 1. So we have to change the sign of this. So 1 by minus 1 minus 2 into d dash value is 1. So 1 plus 2 into d dash square value is minus 1. After simplifying, minus 1 minus 2, so minus 3 minus 3 minus 2 minus 5. So 1 by minus 5 sin x minus y. This is particular integral. Therefore the general solution is CF plus PI. So we have to add a complementary function under the particular integral, then we get the general solution. Next problem, this is a third order partial differential equation because the highest derivative in this partial differential equation is 3 d cube minus 7d d dash square plus 6 d dash cube into z equal to sine of x plus 2y plus e power 3x plus y. So here there are two terms in the right hand side. So we have to find out the particular integral for this first and e power 3x plus y. We have to find out the particular integral after that. Otherwise we can find the particular integral for this exponential function first and the trigonometric function second. There is no problem in it. Finally we are going to add all those particular integrals, so we can find the particular integral in any order. There is no restriction in it. So first we have to find out the complementary function. So for finding the auxiliary equation, we have to replace d by m and d dash by 1. So the auxiliary equation becomes m cube minus 7m minus 6 equal to 0. Here there is no m square term. By using synthetic division, we have to find out the root. So first root, assume it is 3, then 1, here first put 0, then 1 plus 0 is 1, then 1 into 3 is 3, 0 plus 3 is 3, 3 into 3, 3 3s are 9, minus 7 plus 9, 2, 2 3s are 6, so minus 6 plus 6, 0, so the first root is 3. Then the cubic equation becomes m square, because this is the coefficient of m square, this is the coefficient of m, so 3m plus 2 equal to 0. After solving this quadratic equation, we get the roots m equal to minus 1 comma minus 2. Therefore the three roots are 3 minus 2 minus 1. Therefore the complementary function is pi 1 of y minus x, this is for minus 1, and plus pi 2 of y minus 2x, this is for minus 2, plus pi 3 of y plus 3x, this is for 3. Next we have to find out particular integral 1, because there are two functions, so there are two particular integrals, so this is particular integral 1. So 1 by d cube minus 7d d dash square minus 6d dash cube into e power 3x plus y. Replace d square value by minus a square, d dash by minus ab, d dash square by minus d dash square. So here a value is the coefficient of x, that is 3. b value is coefficient of y, that is 1. Next we have to find out the value. Oh, this is the exponential case. Sorry, I have said the solution procedure for the trigonometric term, but this is the exponential case. So here we can simply replace d by the value of a and d dash by the value of b. Then we get d cube means 3 cube minus 7, 3 into 1 square minus 6. After simplifying, we get the denominator is 0 because 27 minus 21 minus 6, then the denominator is 0. So in this case, we have to multiply the numerator by x and differentiate the denominator with respect to d. Then we get, if you differentiate d cube, we get 3d square. If you differentiate 7d dash square, this d becomes 1, then we get 7d dash square. This term becomes 0 because there is no d term. So we get this term. Now again we have to substitute d by 3 and d dash by 1. So 3 into 3 square, so 27. 7 into 1, therefore 7. So after simplifying, we get the denominator is 0. Denominator is 20. So x into e power 3x plus y by 20. Next we have to find out the particular integral 2 for the function sine of x plus 2y. So here we have to replace d square by minus a square, d dash by minus ab, and d dash square by minus b square. So we get the term like this. After substituting, d cube can be splitted into d dash d into d square. So for d square we can replace by minus 1. And then here 7d is here, this is d, 7d is here. Next we have to replace the d dash square by minus 4 here. Next 6 into d dash, then d dash square is again replaced by minus 4. So we get minus d plus 7 4s are 28 plus 28d minus 6 minus 4. So 6 4s are 24 plus 6 24 into d dash. So 28d minus d, that is 27d plus 24d dash. Then we have to multiply by d in the numerator and the denominator. Then in the numerator we have d, in the denominator we have 27d square plus 24d d dash. Again we have to replace d square by minus 1 and d dash by minus 2. Then we get 27 minus 48. In the numerator we have d. So after simplifying this, we get minus 1 by 75 d of sine of x plus 2y. So d is the partial derivative with respect to x. So d of sine means we have to differentiate this sine function with respect to x. Therefore, the differentiation of sine is cos, then x plus 2y. After differentiating this function with respect to x, we get 1 plus 0, therefore 1. Therefore, particular integral 2 is minus 1 by 75 cos of x plus 2y. So the general solution is CF plus PI1 plus PI2. So there are 3 roots, therefore the auxiliary equation has 3, the complementary function has 3 terms. First one is pi1 of y minus x plus pi2 of y minus 2x plus pi3 of y plus 3x plus the particular integral 1 is 1 by 20 x into e power 3x plus y. So here we have 1 by 20 x into e power 3x plus y, and the particular integral 2 is minus 1 by 75 cos x plus 2y. Next type 4. Type 4 is the product of exponential function with either the polynomial or trigonometric term. So this pi function may be a polynomial or a trigonometric term. So these two terms are in product. So we have to find out the particular integral for this type of right-handed side term. Let us consider one problem. D cube plus d square d dash minus d dash square minus d dash cube into z equal to e power x cos y. First we have to find out the auxiliary equation. Then we get m cube plus n square minus m minus 1 equal to 0. Therefore, there are three roots. They are 1, minus 1, minus 1. The complementary function is pi 1 of y plus x plus pi 2 of y minus x plus pi x into pi 3 of y minus x. So x into pi 3 of y minus x. Next we have to find out the particular integral. So 1 by d cube plus d dash d square minus d dash square minus d dash cube into e power x cos 2y. This term can be written as d minus d dash into d plus d dash the whole square. Then this first we have to find out particular integral for this case. So here we have e power x cos 2y. So here in the e power x term, a value is 1 and b value is 0. So d can be replaced by d plus 1 and d dash can be replaced by d dash plus 0. Since the original formula is d is replaced by d plus a and d dash is replaced by d dash plus b. So this d is replaced by d plus 1, d dash is replaced by d dash alone. Similarly, d is replaced by d plus 1, d dash is replaced by d dash plus 0. After simplifying, this term becomes so after substituting this value, we can take e power x uh, near this equal to sign. So equal to e power x 1 by this d is d plus 1 the whole cube plus d plus 1 the whole square minus d plus 1 into d dash square minus d dash cube. After simplifying this term, we get 1 by 3d plus 5d dash plus 5 cos. For cos 2y the procedure is same. Here there is no x term, so a equal to 0 and b equal to 2. So a square, that is d square, is replaced by 0 and ab is also 0, therefore d dash is replaced by 0. B equal to 2, therefore b square is 4, therefore d dash square is replaced by minus 4. After simplifying, we get d dash by 5d dash minus 2d into cos y. So take 5 as a common term, then d dash minus 4 we have, multiply by the conjugate, then d dash plus 4 by d dash plus 4. Then the denominator becomes d dash square minus 16. In the numerator, multiply by d dash, then d dash square plus 4d dash into cos 2y. So d dash square plus 4d dash into cos 2y by d dash square minus 16. Now replace d dash square by minus 4. D dash square of cos 2y is minus 4 cos 2y. 4 d dash of cos 2y is minus 2 sin 2y. After simplifying, we get e power x by 25 cos 2y plus 2 sin 2y. Okay, this is the particular integral. After that we have to find out the general solution. The general solution is Z equal to CF plus PI. So we have to add the value of CF and PI, then we get the general solution. Similarly here, exponential function is multiplied with the polynomial x square y square. Therefore it is a fourth type. So first we have to find out the auxiliary equation. The auxiliary equation is m square minus 2m plus 1. Actually this is 1. Therefore m minus 1 the whole square equal to 0. Therefore m equal to 1 comma 1. So the complementary function is phi 1 of y plus x plus phi 2 of x into y plus x, because this is a repeated root. So we have to use x. Next pi. So 1 by d square minus 2 d dash plus d dash square into x square y square plus e power x plus y. So this term can be written as d minus d dash the whole square. So for finding the particular integral x for the exponential case, so a value b value both are equal to 1. So d is replaced by d plus 1, d dash is replaced by d dash plus 1. So 1 minus 1 get cancelled. Finally we have d minus d dash. So d minus d dash the whole square into x square y square. Take d as a common term for converting the first term as 1, because for the polynomial case we have to convert the denominator in either form of 1 minus or 1 plus. So here I am trying to convert 1 minus. So here the power of this factor is 2. So if you take d outside means then it will become d square. So the remaining term is 1 minus d dash by d the whole square. So e power x plus y 1 by d square. Take this term into the numerator, then 1 minus d dash by d whole power minus 2 into x square y square. So e power x plus y 1 by d square. After expanding this, so here this is 1 minus sign, this is 1 minus sign. So all terms are positive. So 1, 2, 3, like that the coefficient are exist. So here x square y square, therefore up to second derivative we need. D dash cube is no need, because d dash cube of x square y square is 0. So there is no need to write 4d dash cube here. So e power x plus y 1 by d square multiply x square y square in each and every term. So x square y square plus 2 by d dash of 2x x square y square. D dash of x square y square is 2x square y. And then d dash square of x square y square is 2x square. So replace d dash square by 2x square. After simplifying we get here 1 by d square is there. So multiply by 1 by d square in each and every term. Then in the first term we have to integrate with respect to x 2 times. The second term we have to integrate 3 times. The fourth term we have to integrate 4 times. After integrating, the final pi is e power x plus y into x power 4 y cube by 12 plus x power 5 into y by 15 plus x power 6 by 60. This is pi. Therefore the general solution is cf plus pi. Cf is this one and pi is this one. So this is the final answer. Next one is fifth case. This is a simple case. F of x comma y equal to sin ax into sin by. Either sin ax into sin by or cos ax into cos by. In the third type already we have studied one trigonometric term, that is sin of ax plus by or cos of ax plus by. This term is entirely different from this third type. So that is f of x comma y equal to sin ax sin bx or cos ax cos bx. So here there is no need of d dash. If d dash exists, then we cannot use this type. Okay, so this partial differential equation is free from d dash. Therefore, d square is replaced by minus a square and d dash square is replaced by minus b square. Okay, that is the idea. Next, we have to find out CF. So write down the auxiliary equation. D is replaced by m and d dash is replaced by 1. So we have m square minus 1 equal to 0. Therefore, m equal to plus or minus 1. CF can be written as pi 1 of y plus x plus pi 1 of y minus x. Therefore, the particular integral is 1 by d square minus d dash square sine 2x sine 3y, because this is our question. So here a value is 2 and b value is 3. So d square is replaced by minus a square and here d dash square is replaced by minus b square. Therefore, minus 4 minus of minus 9 we have minus 4 plus 9, therefore 1 by 5 sine 2x sine 3y. This is a simple problem. Just we have to replace d square by minus a square and d dash square by minus b square. This is for fifth type. And the sixth type, that is the special case, the trigonometric term is multiplied by with a polynomial, that is y cos x or y sin x. So here the trigonometric term cos x is multiplied with the polynomial y. Similarly, another problem is y sin x. So finding the particular integral, we have to use the separate procedure. 1 by d plus a d dash into y can be replaced by integral. Please consider this relation. So c plus ac ax into dx. So this can be written as c plus ax into dx. So for finding the particular integral, first we have to write down the denominator into the factor form, product form. For the first factor, we can replace the factor d plus a d dash, means we can replace it by integral c plus ax into dx. Okay, so let us see one example for this type. This is an important type. D square plus d dash minus 6 d dash square equal to y cos x. So first we have to find out the particular integral, complementary function. Therefore, the auxiliary equation becomes m square plus m minus 6 equal to 0. So here the roots are m equal to minus 3 comma 2. So there are distinct roots. Therefore, the complementary function can be written as pi 1 of CF is pi 1 of y minus 3x. Okay, 1 minute, I will present my screen. Okay. So here there are two roots m equal to minus 3 comma 2. Therefore the CF can be written as pi 1 of y minus 3x plus pi 2 of y plus 2x. So this is the complementary function. Next we have to find out the particular integral. So the particular integral is 1 by d square plus d d dash minus 6 d dash square into y cos x. This d square plus d d dash minus 6 d dash square can be written as the product of two factors. So for this factors, we can use this roots. So the first one is d plus, use this factor. So first one is d plus 3d dash, second one is d minus 2d dash. So d plus 3d dash into d minus 2d dash into y cos x. So already we know the formula 1 by d plus a d dash means into y means integral of c plus ax into dx. So we will find the particular integral for the first factor and then the second. Let us consider the first factor is 1 by d minus 2d dash. So 1 by d plus 3d dash, keep this factor aside. So integral of c minus 2x, because this is d minus 2d dash, it can be written as, instead of y we can replace c minus 2x into cos x into dx. So first term is c minus 2x can be taken as c minus 2x equal to u and dv equal to cos x into dx. So by integration by parts, du equal to minus 2 dx, because c is a constant. After integrating c, it becomes 0. So after differentiating c, it becomes 0. After differentiating 2x, we get minus 2 into dx. Okay, next dv is cos x dx. So after integrating this, we get v equal to sin x. So the formula is integral u dv equal to uv minus integral v du. Therefore, we get u term is c minus 2x. U term is c minus 2x and v term is sin x minus integral integral sin x, that is v, du is minus 2 dx. So this is v du term. So here this is sin x. So minus 2 is a constant term. So minus into minus plus. Therefore this term becomes plus 2. So c minus 2x into sin x minus plus 2 sin x. After integrating sin x, we get a minus cos x. So plus here minus. So because integration of sin x is minus cos x, so we get minus 2 cos x. So y, so for this c minus 2x, we can replace it by y, because c minus 2x equal to y. So we have y sin x plus 2 into minus cos x. So we have y sin x minus 2 cos x. So replace this by uh, in this term. So 1 by d plus 3d dash into y sin x minus 2 cos x. Now we are going to find out the particular integral for this second factor. Therefore, this y can be replaced by c plus 3x in this form. So, this y can be replaced by c plus 3x into sin x. So, here there is a integral term, therefore dx minus 2 integral of cos x into dx. Because here the factor is in the denominator, therefore either 1 by d or 1 by d dash we have to integrate. Therefore, the integral sign exists for the both terms. Now again we have to use integration by parts for the first integral. For the second integral we can directly integrate. Integration of cos x is sin x, therefore minus 2 sin x. But for this first integration, we have to again use integration by parts. Let us see. So here let us assume that c plus 3x equal to u and the db equal to sin x into dx. Then du is 3 dx, v is minus cos x. Then uv minus integral v du equal to the integration of u dv. So substitute all these terms in this formula. So u is c plus 3x, v is minus cos x, minus integral v is minus cos x, dv is du is 3 dx. So this term becomes y, already I have mentioned, and this is minus cos x, therefore here minus sign is there, therefore minus cos x. So here minus into minus plus 3 cos x dx, integral cos x dx is sin x. So substitute this term into here, we have minus y cos x plus sin x. So this is particular integral. So the general solution is complementary function plus particular integral. So pi 1 of y minus 3x plus pi 2 of y plus 2x minus y cos x plus sin x. The same problem, the first problem is y cos x. First problem is the right hand side is y cos x. In this second problem, the right hand side is y sin x. So first we have to find out the complementary function. The same procedure. There are two roots 2 and 3. Therefore, the complementary function becomes pi 1 of y plus 2x plus pi 2 of y plus 3x. Next, we have to find out the particular integral. Therefore, 1 by d square minus 5d d dash plus 6d dash square into y minus sin x. This PDE can be written as the product of two factors. The first factor is d minus 2d dash. The second factor is d minus 3d dash. For writing this factor, we can use this auxiliary equation factor. The auxiliary equation factor is m minus 2, m minus 3. With the help of this factor, we can write this one. Next, we have to find out the particular integral for the first factor, that is 1 by d minus 3 d dash. So this term can be y can be written as in terms of this term, so c minus 3x into sin x dx. Again we have to use the integration by parts term. So we get the final answer is minus y cos x minus 3 sin x. The explanation is given here. So minus y cos x minus sin 3x. After that we have to find out the particular integral for the second factor. So second factor d minus 2 d dash. So we have to use this factor for replacing y. So we have, instead of y we can write c minus 2x. So here minus sign is there, so this is the minus sign, and the cos x term is cos x into dx. So we have to put integral sign. So minus 3 integral of sin x into dx. After you using integration by parts in the first term, so here I have given the detailed explanation. The final answer is y sin x minus 2 cos x. So minus y sin x plus 2 cos x, because one minus sign is in the uh, outside, so minus y sin x, minus into minus plus 2 cos x, here plus 3 cos x, because after integrating sin x we get a minus cos x, so minus into minus is plus 3 cos x, so here 2 cos x plus 3 cos x, so we get 5 cos x, so minus y sin x. So this is pi, therefore the general solution is z equal to pi 1 of y plus 2x plus pi 2 of y plus 3x minus y sin x plus 5 cos x. This is the general solution. So for the integration by part, for the second factor, let u equal to c minus 2x and dv is cos x. Then du is minus 2 dx, v is sin x. Substitute into this formula, then uv is c minus 2x into minus 2 dx, sorry, minus dv is uv, so u is this one, v is sin x, so c minus 2x into sin x minus integral v du, so v is sin x and du is minus 2 into dx. So minus into minus is plus, so instead of this c minus 2x, we can write y sin x, integration of integration of sin x is minus cos x, therefore 3 minus sign, here 1 minus sign, here 1 minus sign, after the integration of sin x we get minus cos x, therefore we get minus 2 cos x, therefore y sin x minus 2 cos x. We are substituting this answer here. Okay, the another one is non-homogeneous PDE. So far we have discussed the homogeneous PDE because the order of each and every term is 2. Listen, so this is d square, this is d dash. So here second derivative, here also second derivative, here d dash square, here also second derivative. So in each and every term the order is 2. The same order is maintained in each and every term, then this is called homogeneous PDE. So far we have discussed the solution procedure for the non-homogeneous, homogeneous PDE. Now briefly we are going to discuss the solution procedure for the non-homogeneous PDE. The difference is only for finding CF, not for PI. So the solution procedure for a particular integral is the same as with the homogeneous PDE. So I am going to explain only about the procedure for finding of a complementary function, that is CF. So this is an example for non-homogeneous PDE. So here the first term is d, that is first order derivative. Second term is minus m d dash, first order derivative. But the third term is a constant term, no derivative term is occur here. So we have to collect the m and c value from this PDE. So here the coefficient of d dash is m and the constant term is c. If the first term is d, then the complementary function can be written in terms of y plus mx. Suppose in this second PDE, the first term is d dash and the coefficient of d is m and the constant term is the same as c. So if the first term is d dash, then the solution pi 1 of x plus my will come. So pi 1 of x plus my, but here if d is the first term, then the CF becomes pi 1 of y plus mx. We have to this thing in our mind for writing the complementary function. So d minus m d dash minus c into z equal to 0. but here d dash minus md minus c into z equal to 0. These two are non-homogeneous, but here the first term is d, therefore the coefficient of d dash is m, but here the first term is d dash, the coefficient of d is m. If the first term is d, then y will exist the first term, but if the first term is d dash, then in the complementary function the first term is x. So this is very very important. If there are many factors, they have same if there are many factors, they have different m1, m2 and mn value, c1 and c2 value, then the solution can be written like this: e power c1x into pi 1 of y plus m1x plus e power c2x pi 2 of y plus m2x plus etc. c power cnx y plus mnx. So we have to collect m1, m2 and etc. mn. Similarly, c1, c2 etc. cn. After collecting these values, we can write the complementary function. If the factor is repeated, then only one m r times, only one c r times, then the solution, that means the complementary function is z equal to e power cx pi 1 of y plus cx. Here the first term is y, since here the first term is d. So here repeated root, therefore we have to write x into e power cx plus pi 2 of y plus mx. So we have to continue in this manner. Then the last term is x power r minus 1 e power cx into pi r minus 1 into y plus mx. Okay. Let us see one example. So here d plus d dash minus 2 into d plus 4 d dash minus 3 into z equal to 0. So here you can see that this is a non-homogeneous PDE, because this is first order, this is first order, but this is uh, no derivative exists. Similarly, here also this is non-homogeneous. So we have to collect the coefficient of m and c. So here the coefficient of d dash is minus 1, because the general form should be d minus m into d dash minus 2. This is the general form. Okay, so but here we have plus, so m value is minus 1. Okay, so c value is plus 2. Similarly here in this second factor, m value is minus 4 and c value is 3. So here there are two factors, so we can write this value is m1 c1 and m2 c2. So the complementary function can be written as, for this first factor we can write e power c1x, therefore e power 2x pi 1 of y plus mx. Y here, y is the first term, means here the first term is d, that's why. So pi 1 of y plus m1x. So pi 1 of y minus x. Plus e power c2x pi 2 of y plus m2x. So e power c2 is 3. So e power 3x pi 2 of y minus m2 value is minus 4x. Okay, this is the complementary function. So here the right hand side is 0, therefore there is no particular integral, therefore the complementary function itself is a solution. Therefore we can write z is this one. Second is 2d d dash plus d dash square minus 3d dash into z equal to 0. Here there is no linear factor, so we have to find out the linear factor first, and then we can find out the value of m and c values. Let us see how can we find out the linear factor. So here in each and every term d dash term is common. Okay. Moreover, this is a non-homogeneous PDE because this is second order. This is a second order. Therefore, the second term is second order, but the third term is first order. So here the first term is the second order, second term is also second order, but the last term is first order. Therefore, this is a non-homogeneous PDE. So in all the three terms has d dash as a common term, so we can take outside d dash. Therefore, the remaining terms becomes d dash plus 2d minus 3. So here d dash minus 0 into d, because here there is no d term, so we can write it as 0 into d minus, there is no constant term, therefore c is 0. Similarly, in the second factor, d dash plus 2d minus 3 equal to 0. So here you can see that the first term is here d dash. Okay. So what did I have say? If the first term is d dash, then the solution can be written as phi 1 of x plus my, isn't it? So first we have to collect m and c values. In the first factor, m is 0. Similarly, c is also 0. But in the second factor, m is minus 2 because d dash minus md minus c. Therefore, m2 is minus 2, c2 equal to 3. So, z is e power 0 y pi 1 of x plus 0 y plus e power 3 y pi 2 of x minus 2y. X minus, because we have to start with the x, m value is minus 2, so x minus 2y. Therefore, e power 0 is 1, pi 1 of x plus e power 3y pi 2 of x minus 2y. So, the third question is t square minus d dash plus d dash minus 1 into z equal to 0. So, here the first term and the last term d square minus 1 can be written as d plus 1 into d minus 1, because we know the formula a square minus b square equal to a plus b into a minus b. So, d square minus 1 can be written as d plus 1 into d minus 1. The second and fourth term we can take d dash as a common term. So, minus d dash, if we take outside, then we get plus d minus 1. So, in these two terms we have d minus 1 as a common term. So, the remaining terms are d plus 1 minus d dash. So, here the first term is d, here also the first term is d. Here there is no d dash term, then the m value is 0, but c1 is 1. Similarly, here d dash coefficient is 1, that means minus 1, so m value is 1. and C2 is minus 1, because the correct order of this equation is here d minus d dash plus 1. Therefore, M2 is 1, but C2 is minus 1. So, Z equal to e power C1 x. Therefore, e power x pi 1 of y plus 0 x. Similarly, here e power minus 1 into x, pi 2 of y plus 1 into x. Therefore, after simplification, we get e power x pi 1 of y plus e power minus x pi 2 of y plus x. Okay, this is the solution. So here right side is 0. So here we are discussing about only the CF, because this is the different procedure for non-homogeneous problem. For finding the particular integral is the same as with the homogeneous problem. Okay, so there is no new method for finding PI. Same procedure what we have seen in the homogeneous PDE. So far we have discussed the solution procedure for first order PDE, that is by linear PDE by Lagrange's method, and a non-linear PDE by Charpit method, and then the subcases of the Charpit method, that is the function of P and Q and Clairaut's form, and the function of ZPQ and the function of XP and YQ. After that we have discussed the first order PDE, but the problem is a Cauchy problem. So Cauchy problem, there are three results are there. With the help of that three results, we can find out the solution procedure. Solution procedure, that is not a solution procedure. It is the nature of the solution, that is a unique solution or infinitely many solution, and no unique solution. Okay, then in the at last we have discussed about the solution procedure of higher order partial differential equation. Okay, before the solution procedure of higher order partial differential equation, we have discussed about the classification of second order partial differential equations. In that we have discussed there are two types. The first type is for the second order PDE with the two independent variables, and then the second order PDE with the three independent variables. After that, we can write the characteristic equation with the help of A, B, C value. If finding the solution for that characteristic equation, we can find out the characteristic curves also. And if the discriminant value b square minus 4ac is greater than 0, then the given PDE is hyperbolic. B square minus 4ac equal to 0, then the given PDE is parabolic. If b square minus 4ac is less than 0, then the given PDE is elliptic. So here for the higher order PDEs, the solutions we have discussed for the homogeneous and non-homogeneous PDE. For the homogeneous PDE particular integral, there are 6 types. First one is exponential, second one is polynomial, third one trigonometric, fourth one is the combination of both exponential and trigonometric, or the combination of both exponential and polynomial. Fifth one is the trigonometric but in the simple form, and the sixth one is polynomial with trigonometric. The next one is canonical form. The canonical form is in the yesterday session I had mentioned that in the next class we will discuss about the canonical form. So the canonical form is little bit difficult. So different procedure for three different types of partial differential equation. Here, due to time constraint, I am going to discuss about only elliptic PDE. So if a second order PDE, the general form is AUXX plus BUXY plus CUYY plus F of XY UPQ equal to 0. If b square minus 4ac is less than 0 means we can say that the given PDE is elliptic. And then the characteristic equation can be written as already we discussed this a into lambda square, a value is the same this one, plus b lambda plus c equal to 0. When we solve this characteristic equation, when we solve this lambda quadratic equation, we have two roots, that is lambda 1 and lambda 2. Because this is less than 0, then the square root value is negative, therefore we get two complex roots. Then dy by dx plus lambda 1 is the first characteristic equation, and dy by dx plus the second root equal to 0 is a second characteristic equation. So here lambda 1 and lambda 2 must be complex roots because b square minus 4ac is less than 0. After solving this these first order differential equation, we get two solutions. Y, let it be zeta and eta. So after finding zeta and eta, we can find out the value of alpha and beta with the help of this formula, that is alpha equal to zeta plus zeta by 2 and beta equal to zeta plus zeta by 2i. Then the required canonical form is of the for the elliptic equation is u zeta zeta plus u eta eta equal to pi of this. This is the canonical form for the elliptic equation. Okay. Therefore, now we will discuss one example for this problem. So this is a big problem, so we can discuss only one problem. After that we will wind up this session. So reduce into canonical form uxx plus x square into uyy equal to 0. So we are going to collect the coefficient of uxx uxx is a, coefficient of uxy is b, coefficient of uyy equal to c. Therefore a equal to 1, b equal to 0, c equal to x square. Then b square minus 4ac is, b square value is 0 and 4, a value is 1, c value is x square, so we get minus 4x square. So here x value is always x square value is always positive, therefore minus 4x square becomes negative. If b square minus 4ac less than 0 means the given PDE is elliptic. Therefore the characteristic curve is a lambda square plus b lambda plus c equal to 0. Therefore a is 1, b 0, c x square, substitute into this. Therefore lambda square, 1 into lambda square plus 0 lambda plus x square equal to 0. So lambda square plus x square equal to 0. So we get lambda equal to plus or minus ix. So the first root is ix, second root is minus ix. Therefore the characteristic equations are dy by dx plus ix equal to 0, and the second characteristic equation is dy by dx minus ix equal to 0. So dy by dx equal to minus ix, dy by dx equal to plus ix. Then after integrating we get y equal to minus I x square by 2 plus integrating constant C1. Here y equal to I into x square by 2 plus C2. So y, after taking this term into the left hand side, y plus I x square by 2 equal to C1. Similarly, the second equation becomes y minus I x square by 2 equal to C2. Let zeta equal to the first solution and zeta equal to the second solution. From this zeta and eta, we can find the value of alpha and beta. So alpha equal to zeta plus zeta by 2, beta equal to zeta minus zeta by 2i. A simple calculation with the help of zeta and eta, then we get alpha equal to 2y by 2, that is alpha equal to y. Similarly, beta equal to I x square by 2i, I get cancelled, therefore beta equal to x square by 2. So alpha equal to y and beta equal to x square by 2 we have. After that, we have to find out the derivative of all possible derivatives. That is alpha differentiate with respect to x and differentiate with respect to y. Then we get the first order derivative and then find out the second order derivatives 2. Then alpha xx equal to 0, alpha xy is 0, alpha yy is 0. Because alpha equal to y, therefore only alpha y exists. All the remaining values are 0, isn't it? Next, beta equal to x square by 2. Then beta x is 2x by 2, then the value is x. And beta y, there is no y term, therefore beta y 0. This is the first derivative with respect to x and y. Next, the second derivative beta xx. Since beta x equal to x, then beta xx is 1. Beta xy, beta x is x, then beta xy means we have to differentiate this term with respect to y, there is no y term, therefore this is a 0. And beta yy, already beta y 0, then beta yy is also 0. So after finding these derivatives, we have to find out the value of a bar, b bar, c bar, all those values we have to find out. Okay, because we have to substitute these value into the canonical form. Let us discuss it later. So first we have to find out a bar. So we have to memorize all these formulas, a bar, b bar, all terms have different formulas. We have to memorize all those things. So a bar equal to a into alpha x square plus b into alpha x alpha y plus c into alpha y square. Substitute all those values. Already we know that a equal to 1, b equal to 0, c equal to x square. With the help of these values, we can find out the values further. So substitute what is alpha x 0. Okay, then what about b 0? C is x square, but alpha y is 1. Therefore, 1 square into x square is x square. So a bar is x square. Next, the formula for b bar is 2a alpha x beta x plus b alpha x beta y plus alpha y beta x plus 2c alpha y beta y. So here alpha x is 0. So alpha x is 0. Here b value 0 and alpha y is 1, but beta y is 0. So b bar value becomes 0 because all the terms are 0. Next, c bar. C bar formula is a into beta x square plus b into beta x beta y plus c into beta y square. Substitute all those values, then c bar equal to x square. Similarly, we can find out the value of d bar and e bar and f bar. F bar is simply f. So here in the given equation there is no f term, therefore that is 0, and there is no g term, therefore g bar is also equal to g, which is also 0. Why we are finding this value means the canonical form general equation is a bar u alpha alpha plus b bar u alpha beta plus C bar U beta beta plus D bar U alpha plus E bar U beta plus F bar U equal to G bar. This is the general canonical form. Now we are going to substitute all those values. Since we have A bar is x square, B bar is 0, and C bar is x square, D bar is 0, D bar, F bar and G for G bar equal to 0, E bar equal to 1. Okay, substitute into this equation. A bar equal to x square U alpha plus B bar is 0 U alpha beta, C bar is x square then U beta beta, D bar 0, E bar 1, 1 into U beta, F bar 0 into U equal to G bar, that is also 0. So we have x square U x alpha plus x square U beta beta plus U beta equal to 0. We can take x square as a common term, therefore the remaining terms are U alpha plus U beta plus U beta equal to 0. Therefore this equation becomes U alpha plus U beta equal to minus U beta by x square. So here most of the terms are in alpha beta, but this only one term is in x. So we have to convert this term also in alpha and beta. For this conversion we are using this relation, beta equal to x square by 2. So x square equal to 2 beta. With the help of this relation, beta equal to x square by 2, therefore 2 beta equal to x square. So instead of this x square we can replace it by 2 beta. Therefore the final canonical for this elliptic form is U alpha plus U beta equal to minus U beta by 2 beta. This is the solution procedure for the canonical form of elliptic PDE. If it is parabolic means then that is entirely different. Similarly, if it is hyperbolic means that is also entirely different. So due to time constraint, I am explaining here only elliptic PDE. Okay. Next we are going to discuss the last topic, that is variable separable method for heat equation, wave equation and Laplace equation and related problems. We will discuss in the next session. Thank you.
Thank you, ma'am.
Thank you, sir.